it cancels out on the right. You can see that those go away. But on the left, you cannot combine terms. So what's left over is x plus y equals -2.
Okay.
Is that okay for the moment?
Yeah.
Okay. So there's a bit more here to standard form. The first thing I mentioned, though, is that both x and y are on the left. That's our first kind of guiding principle. We're going to look at question 2, and we're gonna add to it. So let me grab question 2 and snip it in here. Okay, so it says same instructions here. Need to convert this to what's called standard form, which is this ax plus by equals c. So the first thing is that x and y are on the left. The second thing is that there are no fractions. So that what the definition, though, it would say a, b, and c are integers. Okay, so whenever you see a fraction to start out, you want to eliminate that fraction. Do you remember what you would multiply everything by to eliminate that fraction, that 1/2?
No.
So it's always what's on the bottom. So the number
Oh,
on the bottom here is 2. And so we're going to multiply everything by 2. It just so happens there's a 2 there as well. You're multiplying the y by 2. You're going to multiply the 1 by 2, and then the -1/2 by 2. So this becomes 2y equals -2 over 2x plus 2. What does 2 over 2 reduce to? Can you tell me that?
1.
1. So it becomes 2y equals -x, or -1x if you want, plus 2. How do we move this -x to the other side of the equation?
You add it.
You add it. You add x to both sides. Since you cannot combine x into y, you leave it. X plus 2y equals 2. Okay. So our two rules for standard form are confirmed here. X and y are on the left, and then no fractions. So x and y are on the left, and there's no fractions. Would you agree with that?
Yeah.
Okay, so that's your final answer. So trying to show you it's a recipe. You know, in the second problem, we cleared the fraction. You always want to clear fractions first. Okay, so we'll see that again here in the third problem here. Any questions so far, or do you need any time to get this down?
No.
I will be sending it to you at the end as a PDF, but it's always good to take some notes along the way. All right, so let's look at question 3. Same set of instructions here. It says to convert to standard form. Okay, so notice again that there's a fraction.
Yeah.
And you should immediately say out to yourself, I want to get rid of a fraction. And in the previous problem here, if you scroll up here, the previous problem, we multiplied everything by 2 because there was a 2 on the bottom. In this problem, go ahead.
By 5.
Yeah, perfect. Yeah, so you can multiply both sides by 5, and you're multiplying everything by 5. It's not just one side or one thing. You're multiplying everything by 5. So that's 5y equals 15 over 5 times x minus 15. Can you tell me what that 15 over 5 reduces to?
3.
3. So we have 5y equals 3x minus 15. And our rules for standard form, x and y have to be on the same side, and then no fractions. So how do we get this 3x to the other side of the equation, to the left side?
Subtract it.
Subtract 3x from both sides. So you get minus 3x plus 5y equals minus 15. And you might think to yourself, hey, I'm done, right? I've got x and y on the same side, no fractions. There's like a third requirement here. It's that the number in front of x must be positive.
Oh, yeah.
It's like a little twist at the end, a little wrinkle. So you can make it positive by multiplying everything by -1. And I like to think of it as just changing the signs of everything. I don't get too caught up in like, is it a negative times a negative, or just change the sign. So the first term was negative 3x. Now it's 3x. The second term was positive 5y. Now it's minus 5y. The number on the right was minus 15. Now it's
15.
positive 15.
Okay. Mhm.
Would you like to try one on your own, or would you like us to just move on to question 4 about sketching the graph of each line?
Try one on my own.
Okay, so let me give you a quick problem here. Let's say it's y equals minus 1/3 x plus 2. I want you to convert that to standard form. And if I need to scroll up, please let me know.
Okay. Mhm. Okay, I'm stuck.
Okay, did you clear the fraction?
Yes.
What did you multiply everything by?
3.
Perfect. Okay, so it's 3y equals, now that 3 goes to the 1, so it becomes minus 3 over 3x plus 6. Do you have this written down?
Yeah.
Okay, 3 over 3 is 1, so that negative just comes with it. And from here, you have to get x and y on the same side. So you're going to add x to both sides. Sorry to interrupt you there. So you get x plus 3y equals 6. Where did you get caught up in this
It
problem?
was at the or adding the x part. I didn't understand how you got the x, just x. What
Yeah,
happens?
I mean, you're adding 1x, but at some point you stop writing it. You probably saw that last year or year before.
Mhm.
But you undo subtraction with addition, you undo addition with subtraction.
Okay. So, okay.
Would you like to try one more or move on to something else?
Try another one.
Okay, let's go y equals 3/4 x minus 1. How are you doing on this one?
I'm kind of stuck at the same part.
Okay, so did you multiply everything by 4?
Yes.
Okay, so 4y equals 12 over 4x minus 4. And then you reduce the fractions. 12 over 4 is 3x minus 4. Are you at this line right here?
Mm-hmm.
Okay, so it's 3x is positive. It's not written, it's implied.
Mm-hmm.
So you undo positive with subtraction. You subtract 3x from both sides.
Okay.
Okay, so
Guess
that
that's
leaves you. Go ahead.
confused. I get confused. We just. Oh. Oh, okay.
It's okay. I mean, if you haven't done this in a while and you know it's going to be on the test, we should go through it as much as we can, so that way you've got it down for the test.
Okay. Can I do another one?
Yes, but we're not quite done with this one. Even though
Oh,
x and y are on the same side and there are no fractions, what's the problem with this number out in front?
it's negative.
Yeah. So how do you clear the negative in this case?
We just switch it.
You can just change the signs.
Yeah.
3x minus 4y equals 4. Some students like to divide instead of multiply. It does not matter to me. It doesn't matter to your instructor. You just need to get that answer down there.
Okay.
Okay, let's try one more, like you said. Y equals minus 2/5 x plus 3. Go ahead and give that a try, please.
Okay. I think I got it.
All right, what is your final answer?
5x plus 5y equals 15.
Like this?
Yes.
Okay, so let's take a look here. So we're going to multiply everything by 5. So 5y equals minus 10 over 5x plus 3. Is it clear why I wrote minus 10 down here from the minus 2? Okay.
Yeah.
What does this reduce to? What is 10 over 5?
5. Wait. Oh, 2.
Yes, negative 2.
I was.
Okay, so I mean, really good, except for the small error on reducing, because you add that 2x to both sides. You're close. I mean, it's something where, as an instructor, I'd be like, well, I wonder why she wrote 5, but pretty close. And actually, but pretty good overall. Okay, let's move on to some other questions. We can come back to this if we have time. We got to make sure we get through everything. Or hit the most stuff we can when doing this. Oh, this one's not very good. Let's hoping this was slightly nicer. All right, so there's a couple of different ways you can graph an equation of a line, and probably the most like direct way that always works is to put it in what's called slope-intercept form, and that is y equals mx plus b.
Oh,
Okay, so we're essentially going to take this equation, we're going to solve for y. That is slope-intercept form down here. Okay, so I'm going to rewrite the equation and we're going to solve for y. So I'm going to subtract 5x from both sides. Okay, now I'm subtracting because 5x is really, really positive. Okay, now this is my preference and I think you'll like it. That minus 5x should go before the 3. It should be minus 5x plus 3. It's a small little thing there, but really important to remember that. Okay, and then have we solved for y in this line? Is y completely by itself in this line here?
oh, what was that?
The question I'm asking is y solved for? Is y completely by itself?
Yes.
What about this 3?
No.
No. So then we got to get rid of that. Now 3 is multiplying y, and you undo multiplication with division. So you divide everything by
3.
3. Yeah. So it's just like when we multiplied everything by 3, we're now going to divide everything by 3. So this now becomes y equals minus 5 over 3x plus 1.
Okay.
And very important is that you see that this is now in what's called slope-intercept form.
The -5/3 is the slope.
That's correct. And what about the b value?
1.
1. Great. So when you graph something in this form, you first graph the b value.
Okay.
So that's along the y-axis here, the y-axis. So you graph that point 1 right there.
Mm-hmm. Mm-hmm.
Now the slope, you use the slope from that point, but you have to determine whether you're going up or down. Is -5/3 going up or down?
Down.
Down. So it in words, you're going down 5 because of the negative, and then you're going right 3. You're always going to the right, but the top could be up or down 5. So you just, from that point, you just count. Okay, 1, 2, 3, 4, 5, and then right 1, 2, 3, and you get to that point there.
Okay.
So if you haven't done that in a while, it'd be good to review that. And then you really only need 2 points for a line. So you could just finish it off with by connecting these. I mean, that's probably the best thing for us to do here. The other point is here, just to give us a place to connect them like that. Any questions on that?
No.
All right, we're gonna do 6 next because it's more like 4, and then we'll come back to 5. All right, so we got 3x minus 5y equals 10. You definitely want to solve for y. Okay, so I'm going to write that equation, 3x minus 5y equals 10. And to solve for y, you first need to undo this 3x here. So should we add or subtract to undo it?
Subtract.
You're going to subtract 3x from both sides. So this negative in front of the 5y, or subtraction 5y, that goes with it. So that's going to be minus 5y equals, and then it's better to try to put that minus 3x in front of the number.
Mm-hmm.
Now, same question as before, is y by itself?
No.
No, they got this minus 5 in front. Now it's multiplying. Minus 5 is multiplying the y. It's not subtracting. So you undo it by dividing by whatever's in front. And you divide everything. It's not a choice. It's not a decision. It's everything.
Mm-hmm.
So on the right, it becomes 3 over 5 times x
Mm-hmm.
minus 2.
-2.
So if any of this is unclear, definitely review the notes, review the YouTube, and make sure you can do this. Because from this point, it's if you don't have the equation right, you can't get the graph right, because you need to identify the slope and the b value.
It's it up 3, right 5,
That's correct. And what about the b value?
2, or is it like -2?
It's -2. Yeah. So which one do you start with? Do you start with the slope or the b value when you're graphing?
The b value.
The b value, yeah. Okay, so you start with the b value, put a dot there at -2, and then like you just said, you're rising 3 or up 3, right 5. So you just count from that point, 1, 2, 3. Then you go right 1, 2, 3, 4, 5, put a dot, and that's probably enough. I added the dot the last time. I'll do it again here, but you would get close enough with that.
Mm-hmm. Okay.
Any questions on that?
No.
Okay, so let's talk about number 5 now.
Mm-hmm.
Let me grab that. Here we go. Okay, so I'm going to give you kind of the shortcut here for these. Whenever you have a graph that's y equals a number, and you're going to have to
Mhm.
remember this, this is a horizontal line through that number. I guess through is THRU. Through that number. Maybe it's TH, I don't know. But it's through that number, it goes through that number. Okay, so in this case, it goes through -2. There's -2. A horizontal line, you can think of the horizon. When you look out in front of you, that's the horizon.
Yeah.
And that's your equation. So you have to remember this. You have to, because you'll probably get this one or the one I'm about to show you, and you want to be able to do both, and you don't want to mix them up. Okay, so
Okay.
let's do a vertical line. So let's say I wanted you to graph x equals 4. X equals a number is a vertical line through that number. Actually, I'll just snip in another graph here. So it must go through 4, and you draw it on the x-axis though. I mean, the only way you can really mess this up is if you mix the two of them up.
Okay.
You know, somehow you got to think of verticals like columns. I guess that's a good way to remember. But you have to be very clear between those two.
Mm-hmm.
And this is all review, by the way. I mean, you probably did all of this last year.
Yeah.
So it's not it's not like this new stuff. So let's look at unit 3 review part A, and we'll start taking a look at some of these
Oh, it's like finished, but I don't know if they're right.
yeah, we'll take a look at them. I'll give you some information that you don't have on here.
Mm-hmm.
Okay, so it tells you whether it's complementary, linear pair, or adjacent. So you have to know that complementary means 90 degrees. And yes, that's true. So that one's correct. Number 1 is completely correct.
Okay. Well, my teacher, he said that it was complementary adjacent.
Okay,
But
they are adjacent, but let's so adjacent means that they're next to. And the way this reads is that it's one of the 3. It's not more than one.
okay.
But if your instructor wants adjacent, all the angles that are next to each other are adjacent.
Okay.
So the definition of adjacent, I guess we should talk about that real quick. Adjacent angles share a common vertex. Okay, and you're like, what does that mean? Well, if this is a vertex and there's an angle and there's an angle, A and B are adjacent because they're next to each other.
Okay.
In a right angle, which we just saw, A and B also share a vertex.
Mm-hmm.
Okay, so in a linear pair, which is the last one here, these also share a vertex. So so the answer is that if it's complementary, it's almost always going to also be adjacent. And same thing with linear pair. it's also adjacent. And hopefully the next one isn't like a violation of this. So like number 2, they share the same vertex. Let me snip that in. Okay. So the like if I redraw this slightly, which I'm not changing it at all, I'm just excluding one ray in this diagram. Do A and B?
For this one, I got linear pair.
Yeah, it's definitely a linear pair, but are they also adjacent?
Yeah.
They're also adjacent because they share the same vertex. Now, what does it mean for it to be a linear pair? So they fall on a straight line. But more specifically, the measure of that line is 180 degrees. So these two angles right here actually add up to 180 degrees.
Mm-hmm.
All right, so now when I look at number 3, see, so let me back up here. If the reason I think the worksheet is written, I think they're going to give you a problem where they are not 180 degrees or 90 degrees, and then they would just be adjacent. But so far they've all been adjacent. Like A and B share the same vertex again.
Mm-hmm.
So they're definitely adjacent, but they're also complementary because they also add up to 90 degrees.
Oh, yeah. Okay.
So complementary and adjacent. All right, so let's look at number 4. All right, number 4, they're definitely adjacent. That is true. Okay, because they're right next to each other. They share the same vertex.
Mm-hmm.
Okay. Question to you though is do they add up to 90 degrees? And if you're not sure, you have to remember that this right angle, so this line forms 180 degrees. So this right angle means there's also a right angle over here.
Mm-hmm.
So they are also complementary because they add up to 90.
Okay. And
5 is the same. It's such an odd worksheet because it's like we're getting the same answer on every single one.
yeah.
So this is the same. The two angles add up to 90, so they're complementary, and
Mm-hmm.
they're next to each other. They share a vertex, so they're adjacent.
Yeah. Mm-hmm.
Okay, now 6 is finally an exception to this. And you've done it correctly. They are definitely vertical. Okay. And now we just need to talk about, well, why are they not the others? Why are they not anything else? So they're not adjacent because they're not next to each other. And you might think, well, they kind of look next to each other. Well, so like if A were also up here, then it would be adjacent to B. Okay. And if B were down here, then it would be adjacent to A, but they're not. They have to literally be right next to each other. They have to share the ray between them. They have to share this middle part. So you can almost think of it like, do you have a brother or sister?
Yes.
Okay, so like it's like your room. I'm sorry, your room is this one right over here, and then their room is actually, that's a bad example. Let me undo that. You've got an oddly shaped room, but your room is here, and their room is on the left. You share a wall. Those are adjacent.
Mm-hmm.
They have to share that middle part.
Oh, okay.
All right, let me know when we can move on to number seven here.
Yeah. Yeah, I'm okay to move on.
All right. Question already?
Isn't it because it's on the same side or something like that?
So
It's
go ahead.
it's gonna be 135 still.
The answer is 135, yes. But let's give it some formal names. So this type of problem is called two parallel lines. Do you see the parallel lines?
Mm-hmm.
Cut by a transversal. So this thing right here is the transversal. Okay, and then there's regions. There's the exterior region, the interior region, and then yet another exterior region. And within the two parallel lines cut by a transversal, there's a number of things that are true, angles that are equivalent. So the first one, which is the reason your answer is this, is there's what's called alternate interior angles. So I'm just going to label these A, B, C, and D. Angle A is congruent to angle D. That's alternate interior angles. And they are on the opposite sides of the transversal, but they're in the interior. They're in the interior region, but they're opposite sides of the transversal. It is also the case that angle B is congruent to angle C, and that's what you used in this last problem.
Yeah.
Okay, so you have to remember what alternate interior angles are, because there's actually only two answers to this question. The answer is it's either 135 or it's 180 minus 135. And if it were a multiple choice test, there'd only be two answers. And you don't want to guess on true false, because it's too easy to miss something about it. You just want to do it, get the right answer, and compare it. Okay, let's look at number 8. It's related. It's two parallel lines cut by a transversal.
Mm-hmm.
So what say you? What do you notice about these?
They're both inside.
They're both in the interior, and
Mm-hmm.
they're on one side of the transversal.
Transverse.
So these are also considered alternate interior angles.
Mm-hmm.
So the answer is that this is also 98 degrees. Usually they want a justification in these problems. I know on the worksheet it doesn't, but you may be asked for that on a test or a quiz. All right, so let's look at another situation. We're going to talk about what are called corresponding angles. So the corresponding angles are congruent. So I'm gonna draw a couple lines here. So A, B, C, D, and angle A is congruent to angle C. So notice A is kind of top left and top left
Mm-hmm.
to this intersection,
Mm-hmm.
and that makes them corresponding. Angle B is congruent to angle D, also by corresponding.
Mm-hmm.
Okay, so now we can add in a couple of more letters here: E and F, G and H. Angle E is congruent to angle G because it's in the same relative position. It's from the intersection point, it's lower left, intersection point, lower left.
Uh-huh.
And then similarly with F, angle F is congruent to angle H because it's lower right and lower right.
Okay.
Okay, so you have to remember all this.
Mhm.
It's there's no way to get around it. Same thing with the alternate interior angles. You want to know that as well. All right, so now, why did Matthew show you that? Because you need it for 9 and 10.
Mhm.
And I'm helping here because I'm saying, oh, I'm showing you the corresponding angles, and then I'm giving you a problem with corresponding angles. On your test or quiz, you will not be given that. You'll have to figure that out on your own.
Mhm.
So do you see that 133 degrees is like angle C?
Mhm.
And we wrote here angle C is congruent to angle A, which is the top left. So
Yeah.
that question mark is also
130.
100. Yeah. There's no work to do. There's no like steps. There's just what is the answer. Similarly, we'll do number 10. For number 10, you should notice that angle 114 is like angle H. Angle H is congruent to angle F, which is right there. So that's also 114 degrees.
Okay.
So you might reasonably be like, I got it. I can do this. I'm all set. So 13, 14, and 15 we'll do next. We'll come back to 11 and 12. 13, 14, and 15, you have to decide whether they are corresponding or alternate interior. So let's look at number 13 first. Are these two angles corresponding or alternate interior?
Corresponding.
They are corresponding, I agree. Angle Y is congruent to angle X, but the reason is that they are corresponding. All right, so let's look at 15 next. Same question to you. Are they corresponding or alternate interior?
Mm. I got alternate interior.
They are alternate interior. Check with your instructor, see if they need you to spell these out. Sometimes they grade for spelling, even though they don't most of the rest of the course. So something to ask so going into it.
Mhm.
All right. All right, now for number 14, I'm going to give you the answer, and I want you to tell me why this is the answer. These are not corresponding, and they're not alternate interior. Y and X are actually vertical angles. And you did this correctly on the previous side. Can you give me some words as to why angle X and angle Y are vertical angles?
They share the intersecting parts right there.
They do share a vertex, but they're kind of like, it's kind of like they're
They
not.
I forgot what it was. I was doing it today.
Yeah, I was hoping you had some better words than I have, because it's visually for me, I see them, but it's like two opposing angles that just happen to share a vertex.
Yeah. Mhm.
Okay, now what do you know about vertical angles? What is it true about angle X and angle Y? What can you say about them?
They're like across from each other.
In terms of their angles, what do you know about their angles?
They're 180.
Nope, they're congruent.
Oh, congruent.
Congruent. So there's really two things you see in geometry over and over again. The first is that they're congruent, they're the same. Like the alternate interior angles were congruent. Corresponding angles were congruent. Vertical angles are congruent. Sometimes they add up to stuff. Complementary angles add up to 90. Linear pair add up to 180.
Mhm.
All right, so let's go back and do 11 and 12. We now have enough knowledge to be able to do those. All right, so question 11 here, it just is to find the measure of angle B.
Mm, 71 degrees?
Yes, because they're vertical angles.
Mm-hmm.
There's no work. If I were given the test, I'd want you to justify it with like a word or phrase like vertical angles or something like that. But you know, it's up to your instructor. How about the bow tie here? What is the measure of angle?
79.
79. You got it, and you got to put the degree symbol.
Mm-hmm. Okay.
Is that okay?
Yeah.
Great. All right, so I think we've covered everything on these 2 pages. So if it's okay with you, I'd like to go back and do some more slope standard form problems with you, like we
Yeah.
did in the beginning. But this is a time if you had any questions at all on anything, we should redo those problems. So let's say it's y equals minus 2/3 x plus 4. I want you to write this in standard form.
Okay. Oh, and this is backwards.
How are you doing on this one?
Um, good.
Okay.
Oh, equals. Is it 2x plus 3y equals 12?
That sounds pretty correct here. Let me just work through the steps here, just in case you want to see them later on. So you multiply everything by 3. 3y equals minus 6x over 3 plus 12. 6 over 3 is 2 minus 2x plus 12. You add the 2x to both sides. So yes, your answer is 2x plus 3y equals 12. All right, very good. So new question here. Let's see here. Is x equal 5 a horizontal or vertical line?
It's vertical.
It is vertical. Very good. Okay, y equals negative 3/2 x plus 2. What is the slope and what is the b value?
The slope is -3/2, and the b value is 2.
Okay, now when we look at the slope, can you tell me in words what you would be doing from the point of 2? Like, tell me in words what this actually means in terms of the graph.
You go down 3
Okay,
and right 2.
perfect. That's great. Very good. Okay, so new question here. Let's say J equals 46 degrees. What is the measure of angle M?
46.
Okay, and can you tell me the reason that this is 46?
Because it is a Oh, it's corresponding.
It is corresponding. Very good. All right, I think you've got it. I think if you take some time to review the notes between now and your quiz, you probably have it down. If you get some new stuff that's on the test or quiz, please, consider scheduling a lesson. But yeah, thanks for letting me help you today. I will not be available next Wednesday, but if you need something on Monday or Tuesday of next week, I'd be glad to help you out before your test or quiz or over the weekend as well.
Okay.
I'll send you the notes here shortly, and I'll see you next time. Hope you have a great rest of your weekday.
Okay, you too.
Okay, bye now.